Hello, and thank you for joining us for the fourth installment in our Webcast series, which is focusing on REST services with Jax RS and JQuery. In addition, we have created a JSF 2.0 application that we'd like to share with you. Also, just a reminder, please use the functionality in the viewer for the webcast to submit questions during the webcast such that we can prioritize them during the webcast and answer them at the end. Thanks. Here's the agenda for today's session. We'll be giving an overview of Jax RS and comparing it with SOAP, showing you how to configure WebLogic to support Jax RS, walking through the code for Jax RS, and showing a jQuery application and code. And then finally, we'll wrap it up by showing the JSF 2.0 application and performing a code review so you can become familiar with that code. REST is short for Representational State Transfer. The Java standard for REST is Jax RS, and it is the product of JSR 3.1.1. The general approach to RESTful services is to provide access to resources which represent data. So your resource would be a POJO, and then you would have a URI that has a path template, which includes an ID that allows you to access that resource. REST uses simple nouns, or for resources, and verbs, which are HTTP methods. The HTTP methods are get, put, post, and delete. So you can see how those map nicely and easily in a canonical model to resources. So you can get a resource, you can put a resource, or you can delete a resource. REST places emphasis on simple, stateless point-to-point communications over HTTP. It's not a broadcast format. It's simply from going from a data producer to a data consumer. REST also supports multiple data formats, including JSON, XML, text, and XHTML. And this content negotiation can be specified at runtime using HTTP headers or the URI. Jax RS is heavily annotation driven. You can specify @path and @produces, @consumes annotations at the class level, and then override them at the method level. Then for each of your methods, you specify the HTTP verb, and you can optionally specify path or query parameters that are part of the URI that get passed into the method. So before we take a look at the code, I'd like to give an overview of Jax RS. Jersey is the reference implementation of Jax RS and is the implementation that you will find in both WebLogic Server and Glassfish. Let's take a look at the programming model. First, if you stick with the best practices and the standard approach to REST, you will be creating services out of resources. At runtime, you will be able to generate a WADL file which represents the URIs and supported HTTP methods or verbs, being get, put, post, or delete, and you can use these to create client-side applications. The Jax RS specification only provides details for server-side APIs, but if you use Jersey, then you can take advantage of the classes that it offers to consume REST services as well as create them. Just like SOAP, the container will take care of mapping your data representation, whether it is in XML or JSON format, to your Java POJOs. In addition, Jax RS takes care of HTTP handshaking and allows you to perform content negotiation at runtime. Also, Jax RS supports HTTP communication only. There are no other transports supported. Here's an example of a simple annotated class. You'll see that there is a path annotation at the class level which specifies widgets. If you add additional path annotations at the method level, then they will be relative to the class level path annotation. In addition, you can specify at a class level that this service will be producing specific media types. And here we're specifying that it will provide both XML and JSON formats. And then you can see for the get operations that we have here for get widget and get widget list that we are using the @get annotation to specify that this will support the HTTP GET operation. And finally, if you look at the get widget operation, you will see that there is a template with the ID field being in brackets. And then we specify that the path parameter of ID is getting assigned and proxied to the parameter of the method widget ID. Here's an example of our WADL file. One of the main differences between a WADL file and a WSDL file is that the WADL provides operations and endpoints for your resources, whereas a WSDL file provides the operations that are exposed and their endpoints, but in addition provides a schema definitions for the messages that should be sent and that will be returned. And this includes schema definitions for the objects that will be sent and returned, in addition to the methods that are exposed. So once you deploy a Jax RS application using Jersey, you can get the WADL file by using the host and port where the application is deployed. And then after the root context and application path, you simply add application.wadl, and then you can access the generated WADL file. One of the popular debates in terms of web services right now is REST versus SOAP. When should you use REST versus SOAP, or vice versa? And can REST completely replace SOAP? So let's take a look at some of the arguments and background there. SOAP stands for Simple Object Access Protocol and represents an evolution over XML over RPC, where you would use things like Corba or DCOM or another ORB to share data or objects across network boundaries. And the approach to SOAP is to expose operations that implement logic. So there would be a submit order operation, and you would have a XSD object schema definition for what an order looked like. And SOAP does provide loose coupling for integrating diverse systems, and that's really what it was designed for. It's designed for distributed computing, and it's designed to be extensible. And you will find many WS Star standards that extend the SOAP specification. SOAP also offers standard error messaging using SOAP faults with standard code and subcode for error types. And SOAP aligns very nicely with enterprise application needs and goals. It supports transports other than HTTP, which includes SMTP and JMS, to name a few. And it supports enterprise security with WS Security. It's also language neutral, platform neutral, and transport neutral. And it is ACID compliant and supports atomic transactions with WSAT, supports reliable messaging with WSRM, and provides easy governance through strong typing. In addition, because of its maturity in the marketplace, there is a broad set of development tools that you can use to build both client-side and server-side artifacts for SOAP services. Next, let's take a look at REST and SOAP side by side. As we said before, REST is focused on exposing resources which represent data, whereas SOAP is focused on exposing operations which represent logic. In addition, REST is mainly point-to-point, whereas SOAP is designed to be loosely coupled for distributed messaging. So in addition to point-to-point, which is supported in SOAP, there's asynchronous messaging and pub-sub model that you can use with SOAP. SOAP also supports stateless and stateful conversational operations, whereas REST is focused mainly on stateless communication. In addition, one of the big differences with SOAP is there's very strong typing. And in your WSDL definition for SOAP, you'll find not only schema definitions for your operation input and output, your request and response, but also schemas for your data objects. Whereas when you look at REST, a WADL file provides the URIs, operations, resources, and formats that are generated by the services. So those are some of the main differences. So there's two sides to the argument. One is that REST is better, and obviously the second is that SOAP is better. Here's some of the arguments why REST is better. REST can be consumed by any client, even a web browser, with Ajax and JavaScript. It's lightweight and doesn't require any XML parsing, and doesn't require a SOAP envelope for every message that goes to and from a service provider. And this is very true. Since you don't have to parse XML, the requirements on the client side are much lighter than if you did have to work with XML. And since you don't have to provide a SOAP envelope for all of your requests and responses, then the amount of data that goes back and forth between a consumer and a producer is not as big as with SOAP. One of the other arguments is that SOAP is old and all the cool kids are using REST. If you look at the current consumer-facing web sites like Twitter, Google, Flickr, Facebook, and so on, many of these are using REST services. And it's very easy to learn how to use REST. It's just nouns and verbs and resources. So I can get a customer object, I can delete a customer object, and so on. It goes very well with the canonical data model of resources and verbs and actions. Plus, there's an argument that REST is pretty safe, that you can filter out requests that are not GET operations and then look more closely at those, while allowing GET operations to flow through a firewall more easily without too much inspection. So that's an interesting argument, as long as you stick with a RESTful model and that your GET operation only does a read and does no write whatsoever. So these are some of the arguments, and now let's take a look at why some people would say SOAP is better than REST. So one of the challenges with working with RESTful services is that it's difficult to build a client for REST sometimes. Whereas if you have a WSDL, you can easily generate client-side artifacts like a client proxy. With REST, if you're going from scratch, then you might have to write raw HTTP calls. And in addition, you have to utilize the HTTP error codes to see success or failure. Whereas with SOAP, you can use the SOAP fault, and you can also use your custom exception types and codes in order to do error handling. Plus, many IDEs currently support SOAP development, and many of them have rich features around supporting SOAP development, both for the client code and for the server-side APIs. One of the other arguments is that REST only supports HTTP or HTTPS. One of the problems with HTTP is that it is synchronous, and every good enterprise architect knows that you need asynchronous processing or asynchronous messaging in order to support scalability long term. If you have to service all of your requests in a synchronous fashion, that means in order to service additional requests or to provide your service to additional consumers, you have to provide more threads within your application server or within your enterprise service producers in order to support those requests. Whereas if you use asynchronous messaging, you can support additional consumers by using the same number of producer threads. So the approach to asynchronous messaging is to decouple the thread that is servicing the consumer from the thread that is providing the service or executing the business logic. In addition, REST, in terms of enterprise level security, REST is not as secure as SOAP, especially if you include parameters as part of the URI. So these are the query parameters, not the path parameters. In addition, there's no support for acquiring tokens for a client-server model, right? Again, we're just putting and deleting resources. Another argument is that REST is not reliable. You have to handle failures with retries, and there's no support for reliable messaging like you'll find in WSRM. In addition, since REST is not strongly typed, it's harder to govern. And you can easily see a proliferation of RESTful services because they are so easy to create and expose your data. There's additional products that offer features for SOAP, such as a service registry, where you can know who is consuming your services and do dynamic lookup of services as well. Whereas the support for RESTful services is not as strong as we currently see for SOAP. So both SOAP and REST have their rightful place within enterprise and consumer applications, and there's no reason they can't coexist and support the same applications. REST is ideally suited for exposing data over the internet or networks in general, and has low bandwidth and CPU requirements. It's also good for creating mashups of different content from various providers on a web page. However, if you look at the enterprise requirements for messaging, you may find that SOAP is a better fit because it offers enterprise features like high reliability with WSRM, transactions with WSAT, security with WS Security, and asynchronous processing of messages. It also supports contract first development, such that if the contract changes, then both the producer and consumer need to be updated in order to handle the change, which in some cases can be bad, but in many cases can be good, especially at an enterprise level when you don't want your interfaces to change without the right level of governance. In addition, SOAP supports stateful conversational operations, such that you can have a conversation with a server and have that span multiple calls and have the same context for those calls. It also has lots of standard support and interoperability with business applications like Siebel and SAP and PeopleSoft, which are important to many enterprises today. It also has great tooling support for both client-side and server-side APIs. So while the learning curve may be shorter for REST, the tool support and ongoing support for SOAP services is very mature. The reason behind creating the Oracle Parcel Service example application for this webcast series is to provide a frame of reference for utilizing different technologies. As such, we tried to design it in a way that was consistent with how you would design a good enterprise application or a good application in general. You obviously start with data, you have business logic associated with the data, and then you provide interfaces that ultimately are consumed by clients. If you look at the libraries that we've created, they have been aligned at these different layers of the application stack. So we have our domain services and business services implemented using EJBs. We have our data services using JPA. And then we have various interfaces that include Spring Web Services and MDPs, Jax Web Services and MDBs, and then finally Jax RS or RESTful services, all of which are utilizing the same business logic and same data access or domain services and can be utilized by different clients like a standalone Java client or a web application such as the JQuery example application that we have. Before we take a look at the code, it's important that we cover how to configure WebLogic Server to support the Jax RS services. You simply have to deploy some libraries, some common libraries, shared libraries to WebLogic Server. And these are the JSR 311-API, Jersey-Bundle, Jackson Mapper-ASL, Jackson RS, and Jackson Core ASL. These libraries can be found in the WebLogic Server _1031 Common Deployable Libraries folder. Now let's take a look at the code. In order to deploy this on WebLogic, I have to define my common shared library references. And these are the libraries that I deployed to WebLogic in order to support the application that you can find in the Deployable Libraries directory under WebLogic Server 1031 Common. Next, let's take a look at the Java code for our Jax RS resources. You can find the code in ops-rest, ops-rest-ws. Here, I have two versions of my parcel and shipment resources. Let's take a look at the version 1 of the parcel resource. Here, I'm specifying the root path URI for this resource. If there's a path annotation at the method level, it will be appended to this URI in order to form the final URI. With my consumes and produces annotations, I'm setting the default consumes and produces settings for all of my methods, unless they choose to override them with something different. Here you'll see that I have a reference for my parcel manager and shipment manager EJBs that when this object is constructed, I look up and hold a reference to. In this simple method, I have a /ping method that I can use to make sure my endpoint is up, and I'm specifying the @get annotation, which indicates the HTTP verb get should be used or accepted for this method. Now let's take a look at the code that I have for retrieving the list of parcels, so returning all of the parcels. I have three versions of this method that are exposed via Jax RS. One is the default method, one is explicitly JSON, and one is explicitly XML. The default method is capable of returning and accepting both XML and JSON, and the container takes care of which content type to return based on the HTTP header that is sent on the request. This is one approach to creating different flavors or different data formats for the same object, and we'll see another in version 2 of this service. Here, you'll see that the path annotation for the list is /all. Therefore, the final URI for this method will be /1/parcel/all. Here, I am overriding the default consumes and produces annotations and specifying that this method will accept both XML and JSON, and it will also return XML or JSON. Here, since I am not specifying an @consumes or @produces annotation, it is inheriting the class level consumes and produces, which is JSON. Here, for the XML version, I'm specifying that it consumes XML and produces XML, and I am overriding the class level annotations. Let's take a look at version 2 of this resource. So here, for version 2 of my service, you'll see that I'm using a 2, not a 1, since this is version 2, and I'm using the same parcel URI after the version. I am also defaulting to consume both JSON and XML and produce JSON and XML for all of my methods. Here are the two methods that are key for this resource. I can either list all of the resources or I can get a specific resource. When I get all of the resources, you'll see that the URI template has a different value. Here, it is taking everything after and including the dot in the URI and putting it into the path parameter of path, which is being proxied to the method parameter path. Here, I am using my EJB reference to look up all of the parcels, and then I'm checking to see if the path indicates a JSON response or an XML response. If the path indicates a JSON response, I'm using a response builder, setting my HTTP status of 200, setting the media type to JSON, specifying the entity that I want to return, and then building the response. If it is not JSON format, it will be XML format based on the way that I've constructed the resource. In the case of using XML, in order to get the construction of the array in a proper fashion, I'm defining a generic entity that is a collection of parcels and passing my parcels array as the parameter, and then I'm using this entity to build my response. This provides the capability of wrapping an array using XML. Here, I am retrieving a specific resource. I have two path parameters, one for the ID of the resource that I would like to retrieve, and the one that specifies the format that I would like returned. Since this is a single object, not a collection of objects, I have a helper method here to build the response for me. Let's take a look at that. Here, since it's passing in an object, I can simply check if it's JSON format and then create my JSON response, similar to the way I do if it is a collection and the method where the collection is retrieved. Since it is a single entity, not a collection of entities, I can specify that I want to return the XML representation of this entity, and it will use the JaxB classes for the marshalling. Next, I want to test my services. So I'm going to retrieve my application WADL file from the URI, ops rest ws is the context root for the application that I have deployed. And then REST-API is the context for my servlet. So I get my WADL file by appending /application.wadl to the end of the URI. Next, I'm going to take my WADL file and create a project in SoapUI, which will allow me to test my endpoint. You'll see that when I import my WADL file, it loads all of the URIs for my resources that I can access. Let's take a look at shipment. So what I want to do is list all of the shipments. So when I hit this URI, it provides me with a list of all of my shipments. And I can also use SoapUI to access a parameterized URI such that I can check a specific format for my XML or JSON representation of my object. So SoapUI is pretty handy, and here's why. What we could do is add a test case and a test suite, and using the parameter 51 I can simply create a new load test, and in this scenario I'm going to run 5 threads with no delay for 60 seconds. And now we can see the speed at which my object is being returned. And granted, this is on a local host, so an average time of 2 milliseconds is pretty good, and it supports 1,400 transactions per second. And so this is one way that you can simply test both SOAP services and RESTful services, and we'll cover SoapUI and how we can test and tune a little bit more in the next session. So in order to consume the RESTful services that we created with our Jax RS library, we created a simple jQuery application using Ajax to pull the data that we are interested in displaying. So jQuery is a client-side JavaScript library designed to simplify JavaScript and create powerful and dynamic websites. It's very popular and used today. Many of the websites that you go to for news or sports information use jQuery to provide rich UI interfaces. And you can find some of the websites that use that using the URL specified here. So jQuery is designed to ease the navigation of HTML documents, make it easier to query and select DOM elements, and then of course take action on those, create animations and handle events. And it also makes it very easy to build Ajax applications that are very closely aligned with consuming RESTful services. It's also free, open source, and both MIT and GNU licensed. Next, let's take a look at the jQuery web app that we built and then the code that is supporting it. We have a fairly basic layout, nothing too fancy, because we wanted to focus on the integration with the REST services and getting that right and getting that to a good state for demonstration purposes. So here we can see that if we list the shipments, there's no shipments because I've cleared them out. And one of the pieces that we have integrated is a create shipment wizard. And of course this is a standard wizard, and it will walk us through the different steps needed to create our shipment. So let's go ahead and fill out the from address. Before I click next, let's take a look at the code that is behind this. So here you'll find the code in the OPS Web UI project that you can download from samplecode.oracle.com. And if you haven't received the URL, it should be in one of the follow-up emails or listed on the Webcast console that you see in front of you right now. If not, you can send me an email and then I can point you to the correct URL. So the wizard is under Create Shipment. And here we have our style sheets and JavaScript definitions. And we'll come back to the JavaScript in a bit. But first I wanted to show you the portion of the wizard for the page or for the section that we're filling out now. At the top we have a list of the steps in our process, and then of course that's listed shown at the top of the screen. And for each one of our wizard panes we have a section of input data. So here I have standard input data, and then I have this button where when I click next, it takes an action, and this is built into the wizard. So if we look at the function, its validate tabs is what takes us from one step to another. So on the first page, I am taking the input fields using JQuery to pull the values out of those input boxes and building an address from that. So if we look at the build address JSON function, you'll see that I'm passing in the different fields for the address and then returning it a JSON object. Then I'm checking to see if the address is okay. Basically what this is doing is just checking to make sure that all the fields have something entered in them, with the exception of address line 2, which is optional. Once I check that the shipment is okay, I'm storing the temporary object in my shipment JSON object, and I'm updating the display at the bottom of the page. So let's go back to the wizard. So I click next, and we'll see that the JSON has been rendered at the bottom of the page. So now let's fill out the from address. Send some packages to Larry. And again, as I click next, you'll see that my address is included in my JSON object below. So here on the parcels page, this allows me to enter multiple parcels. So we'll send Larry 20 pounds of stuff. Then when I click add parcel, it's actually using Ajax to add the table, or add the HTML to the end of the table for the parcel that I just created. And also you'll see that the JSON object is updated down below. So let's take a look at this functionality. So here I have the fields for my parcel and the input fields for my parcel, and then I have my button here, and when the button is clicked I'm calling add parcel to shipment. Let's take a look at that. So here I have an add parcel method where I'm passing in my JSON shipment object and then the different fields for the parcel. Let's take a look at that. So here I have the parameters for my parcel, and these are the member objects, and I'm creating the JSON object and then storing the values. And then I'm using the push functionality in JavaScript to push an element onto the end of the parcel array. So let's flip back real quick and notice something else. Here you'll see that I'm passing a reference to an object, a jQuery object, that I'm querying for, and that's my parcel table. So this is the HTML table on the right hand side of the screen that stores the data as I click through my wizard. And what I'm doing with that is appending the HTML onto the end of the table. So if I check to see if it's null to make sure that I pass something in, and then I generate a simple table row, and then I append it onto the end of the table HTML. Then I empty the contents, and then I display the JSON on the page. So let's take a quick look at that. JSON has a functionality called stringify, where you pass in an object and then it gives you the JSON representation of that object. And I'm using that to update the JSON display area at the bottom of the screen, which is here. So let's go back and see what we do when we prepare the confirmation page. So now that I've entered in my parcels, I'm ready to confirm my shipment and submit it. Here you'll see that there's a simple table for the confirmation page. And here's the function that I'm using to create the confirmation page. And this is actually getting called on this step in my wizard. So here I'm using similar functionality where I'm dynamically generating a table from a JSON object using HTML, and then appending it, or then I'm setting the HTML value on the section of the HTML page where I want to see it. So for reference, this is the pane of the wizard that we're looking at right now. So let's flip back real quick. So now I've got three tables: my from address, to address, and my parcels. And here I have an outer table, and then I have a div for each one of my tables that I'm going to create. So here I have functions to get an address table from an address object, and then a parcel table from a parcel array. So if we look at the address table, this is pretty straightforward. For an address, there's a known number of fields. So all I'm doing is generating the left side, the left column that has the static information like address, address 1 and 2, and city. And then I'm pulling the values out of the object for the right-hand side. If we look at the parcel array table, it's a little bit more complex because I'm passing in an array of objects, and then I need to append those down at the end of the row for each one. So here I'm creating my table header, and then JQuery has an each function where you pass in an array and then pass in a function, and the function gets called for each element in the array with the index and element values. So for each element in the array, I'm calling the get parcel table row function, which returns HTML, and then I'm appending it onto my existing string. So here, simple logic, looking at the index, doing a mod by 2 to check to see if I have an even or an odd row so I can do the zebra striping on the rows. And then I'm creating the HTML data. So let's switch back to the wizard. And now when I click done, it's going to submit my shipment. Then we get this alert that says shipment created successfully, and then it provides me with the ID. I've intentionally left this with me able to submit multiple shipments for testing purposes. So I've submitted 4 or 5 shipments, and let's see how that functionality is done. So you'll see that there's a button at the bottom of the screen, which is the done button. And here I'm specifying a JavaScript function when the button is clicked to create a shipment, and I'm passing in my shipment object. So let's look at this method. Here, this is defined in ops.js, and I'm passing in a shipment object, and then I'm using Ajax to push that information to the server. I'm specifying the URL, which is the create function, in the JSON format. Then I'm using the JQuery Ajax function with the HTTP put verb for the URL, and of course I'm providing and expecting JSON back. So if the operation is successful, then I'm displaying the alert box on the screen that says the shipment was created successfully. So I take a similar approach for all the other queries that I do, whether it's looking for a shipment, and then I pass in the shipment ID.json as the URL, and then I'm passing in here for my parcel ID to get my parcel ID log. So these are the Ajax functions that we're using to interact with the Jax RS services. So let's take a quick look at the other pages. So now that there's shipments here, I can do list all shipments, and it will pull those from the Jax RS service. I can also list all the parcels and view the parcel log. So if I put in 4 here and click view log, this is also being updated via Ajax using JSON to create the table dynamically. So let's take a quick look at that, and then we'll move on to the JSF code. So here I have got a function where on click I load the parcel log, then I get the parcel log, and I pass it in a function. So I'm passing a function pointer in, or function definition, that receives an array, and then I'm getting the parcel log HTML table from that array and then pushing it into my parcel log div tag. Similarly here, specify parcel log, the parcel ID, and then the JSON format. And then I generate the table in a similar fashion as I do the other table. We've also created a JSF 2.0 application in order to show some of the new features of JSF 2.0. There's a great blog post by Andy Schwartz, and the URL is here, that lists the new features of JSF 2.0 in detail. And I'll highlight some of them here that are used in our application. So in JSF 1.x, you were required to create a faces config XML file and then manage your navigation rules, create your managed bean definitions, and your converter references in that file. As we see with Java EE 6 and 7 and so on, we are moving towards more annotations and less configuration files. And this is very clear for Jax WS, Jax RS, and JSF 2.0, and even JPA for that matter. So one of the great things about JSF 2.0 is its support for composite components. If you want to create a custom tag or a custom implementation of displaying an object, you are no longer required to create a UI component and a renderer and then wire those up in the faces config. And I'll show you how to do that in our code. In addition, it provides good support for Ajax and Ajax notifications, and the navigation is much simpler. You no longer need to define all of your navigation rules in a faces config XML file. There's good support for implicit navigation, such that you can return a view ID from an action, from a button or a link, and you can also put the view ID directly in the action field of your component. There's also support for conditional navigation, such that if a condition is met, the page that a consumer or a customer is redirected to is dependent upon that. One of the other things that's new is a project stage, and when it's set to development, it provides more detailed error messaging, not just HTTP 500, which is what we saw in the past. So you get better support for the component tree and the exception stack trace, and several other features that are very nice for doing development of JSF 2.0 applications. And finally, there is the concept of resource libraries. So it makes it easier to load things like CSS files, images, etc. without having to specify a path to them. You simply specify a library, such as CSS, images, or so on, and then specify a path relative to that location. So you don't have to worry about, // or slash or so on in order to get to your CSS file. So it's a very nice feature. Now let's take a look at the actual application running for JSF 2.0. There's 3 sections to this page. There's a header at the top, there's a content area, and then there's a footer at the bottom. And I'm using a composite in order to create all of my pages here. Let's take a look at some of the functionality. First, I can query for shipments and parcels, and I'm using the prime faces accordion here. I have a wizard for creating shipments. I can list all of the shipments. I can update the parcel log. I can list all the parcels. And I also have an example here for using Ajax and paging in order to pull back results from the database. So let's take a look at the shipment wizard and go through a scenario for the shipment wizard.
So on this wizard, I have a from tab to parcels and a confirmation tab. So let's go through the example and create a full shipment.
So on this page, I'm able to add parcels to a parcel table, and I'm using JSF to add parcels to the table without submitting the form. and this is updating both the HTML and the session object with the parcels. And now I have a confirmation page. When I submit, I get a confirmation dialog, and then my confirmation is displayed here, and I have a notification up here at the top that specifies the shipment ID. So now I can go and query for my shipment by ID and see that here is my shipment. I can also see that in list all shipments, it now has 3 shipments instead of 2. Now I want to update the parcel log for this shipment, and we'll take ID, well, let's go with ID 102. So here, pasting in my parcel ID, and I've got an Ajax status bar at the top. See, it's retrieved my parcel and shown the current log of events there. I have a calendar pop-up where I can specify the date of the event and also specify a message. Now when I click submit, it is sent through using an event. And when I refresh my parcel log, I now see that the event is on the page. And all of this is done using Ajax. So we're almost out of time, but I wanted to provide a quick overview of the JSF code. Some of the key features that I'm using are the annotations for managed bean, setting it to be session scoped and defining a name here, as opposed to defining this in my faces config. And another thing I want to call out here is that I'm using EJB injection to easily wire in my EJBs for my entity managers. If we look at index.html, you'll see that there's not much code here, but the home page actually has a fair number of elements on it. I'm using JSF 2.0 compositions, and I'm specifying a template here in the layout XHTML file. Let's take a quick look. Here, I'm specifying that I have a page, a header, content, and a footer. When I have my implementation pages, such as index.html, I can define a certain area of my composite that I want to override. So in this case, I'm overriding the content section. I also define a header where I'm importing this XHTML. Let's take a look at the header. Here I have a tag for my Oracle parcel service, a form, and then a menu bar with different menu items. Prime Faces makes it pretty easy to quickly create a pretty nice looking UI if you understand some of the JSF basics. One of the key differences between JSF 1X and 2.0 is the ability to provide a view ID directly in an action tag, or if the action specifies a method, the ability to return a view ID from that method and have it be interpreted. Let's take a look at the shipment wizard, which is one of the more complex pages. Here, I am using my composition again, and I'm overriding the content section where I want to have my wizard. I'm using the Prime Faces wizard widget and defining multiple tabs. Another one of the great things about JSF 2.0 is the ability to make custom composites very easily. So in this case, I have an address custom composite where I'm specifying that I want to do a grid input. I'm passing in a pointer to the address or the object that I want to populate, and then I'm giving it an ID. Let's take a look. So here's where I'm defining my composite. It's got an interface section and an implementation section. In the interface section, I specify the attributes that I'm accepting or that I'm expecting for this composite. In this case, I'm requiring that an address be sent as an attribute. Then, in the implementation, I'm using a panel grid layout with a series of output text and input text pairs in order to collect the information to populate my address object. cc.adders.name is the naming convention for accessing the attributes that you're passing into the composite. So JSF 2.0 makes it very easy to create custom composites to reuse either to input data or to display data. One of the frustrating things about JSF 1.0 was if you wanted to display a data table of a complex object on multiple pages, you had to duplicate that code, or you had to use a UI composite, a renderer, and then update the faces config XML in order to support that. So in JSF 2.0, it makes it very much easier to display the same data on multiple pages. So in this example, I have a grid input for my from address and a grid input for my to address. So I'm reusing that code in order to populate my address object. Now let's look at the parcels tab. Here, I have a table to input the parcel details, and then I have a command button to add the parcel to the table. I'm using the Faces Ajax integration to execute the parcel contents, weight, and all the fields to make sure that they are sent to the shipment wizard bean. And then I'm rendering the parcel table, contents, and these fields after I clear them. So if we look at the action listener here, this takes the fields, creates a parcel, and then adds it to the list, such that when I re-render my parcel table, it is updated with the new parcel that I've just created. Finally, let's take a look at the update parcel log page, which is also pretty interesting. Here, again, I'm using my composition and overriding the content section. This section specifies an Ajax status listener, and for the start status, I am using the Ajax loading bar that we saw in the example. And when it's complete, I remove the bar and display done. So when I put in the parcel ID and either hit enter or tab out of the field, I'm listening for the value change, storing the value, and then looking for the Ajax, or looking for the blur event, and then using Ajax to process the input parcel ID and parcel log input, and then update or re-render the parcel details and the parcel log events. Here I'm using another custom composite to input a parcel log event, where I'm passing in an event object reference and then populating different fields on the event. Here I'm using the Prime Faces calendar to populate or to show a calendar where you can choose the date. So we will be following this up with a YouTube video to show a little bit more detail and discuss some of the thought that went into the selection of the different technologies and the approach that we used to build it. But we wanted to share this with you since we had it in a state that was ready to go. So thanks again for joining us, and now we will be answering the questions.